Sometimes we have equations that we can do the square root method to solve. Sometimes we can do factoring. When we can't factor or do the square root, what options always work? Quadratic formula or completing the square. So that's everything we've looked at so far. The last piece, I want to look at inequalities. So when you have a quadratic with a greater than or a less than in it. So just first thing I have up here is really just some pictures that shows you every possible scenario. We know a quadratic can either open up or open down. What determines if it opens up?
Negative in the front or negative or not negative.
Right. If A is positive, it opens up. If A is negative, it opens down. Then yesterday I told you when we were talking about discriminant, the solutions are the same thing as x-intercepts, right? So you could have a quadratic opening up that hits your x-axis twice. Is it possible to have one that only hits once?
Yeah.
Yes, we could have a quadratic opening up or down that only hits once. Is it possible to never hit the x-axis?
Yes.
Yes. So we could have those scenarios. So that's really just showing you every possibility. It can open up or down. It can hit the x-axis 0, 1, or 2 times. We have been finding these solutions, these points on the x-axis. But I could ask you questions about the inequalities. Like in this first picture, if I asked you where this graph was greater than 0. So the x-axis is where it equals 0, so it's greater than 0 from negative infinity to, give me the x value, so A, union B to infinity. Where is this graph less than 0?
0 to 0. A to B.
From A to B. Okay. This one, if I asked you, where is this graph less than 0? Never. This one is always above, so that one's never less than 0. What if I asked you where this one was greater than 0?
Always.
Negative infinity to positive infinity. So I can ask you these less than or greater than questions, and the easiest way is to figure it out by getting our solutions and looking at the graphs and giving an interval based on that. So let's solve some quadratic inequalities. All right, first thing, we're going to start out like if this were an equal sign. So if this were an equal to, we would factor and solve that. So that's what we're going to do first. 1x squared, so we can do the shortcut. X squared breaks into x. What multiplies to negative 12 and adds to negative 1?
Negative 4 and 3.
Okay. If you set those equal to 0, we would get x equals positive 4 and negative 3. You guys agree with that? Okay. So let's just talk for a minute. We have graphed quadratics. We can get pretty precise with this, but we don't really need to be incredibly accurate. These are the x-intercepts. Does this parabola open up or down? Up, because it's a positive x squared. If you needed to double check yourself, what could you do? Yeah, didn't I tell you to grab a graphing calculator? You could absolutely plug this original one in and just double check your graph. So,
Do you want us to grab it?
but I want a rough sketch. It doesn't have to be real accurate, but just to help you and support your answer.
Alright.
I'm asking you where this is less than 0. So less than, that's below.
4 to negative. Negative 3 to 4.
Would these have brackets or parentheses? Parentheses because I didn't say equal to 0. So from negative 3 to positive 4. So what I would expect on a problem like this, I want you to show me where you factored it and got your solutions. I would like to see a graph so I know how you're getting the answer you get, and your actual answer is that interval. All right, let's try another one. So what does that factor into?
Negative 4.
So we get that x would equal positive 5 and -3. Those are the solutions, so that's where it hits the x-axis. Does it open up or down? Up, because it's a positive x squared. You don't have to find the vertex or anything, we're not getting that precise with it. I wanted less than or equal to 0.
Bracket -3 to 5. Bracket.
Less than would be below the axis, equal to says brackets. Bracket -3, 5. So the next one. What would we have to do for this one? Flip and slide. So we get x squared plus 5x minus 24. So what multiplies to -24 and adds to +5?
-3 and
So if we set those to 0, we get x equals +3 and -8. Oh, yes, I did forget that, didn't I? What do I have to do before I do the solution? Yes, thank you. So we get 2x minus 3 and x plus 4. So when you set those equal to 0, what do we get?
3 halves and -1.
It was a positive 2x squared, so it opens up. This time, I'm asking for greater than or equal to 0. So greater than means positive. That means above the axis. So there are two pieces that are above the axis.
-4.
Do we get parenthesis or bracket on it?
Bracket.
Bracket because it was equal to, union, bracket, 3 halves to infinity.
Wait, was there?
Because this time I wanted greater than 0, so above the x-axis, and there are two different pieces.
If it's greater than, and if the graph's opening up, it will be 2 pieces.
Yes.
And then if it's greater than, and the graph is going down, it'll be 2 pieces.
Give you one piece.
Or 1 piece.
But usually, you know, if this were a negative x squared, you would probably multiply everything by -1 first to make it a positive. So then we can decide based on that. I'll do one like that in just a second.
Wait, when you multiply by -1,
Looks
would
like
it flip
that,
your
right?
signs?
Yes.
Okay.
If you multiply by negative, it does flip the anything.
I couldn't remember if it was just voting or not.
Okay, why don't you guys try one on your own?
We're getting close.
All right, slip and slide. So that factors into x minus 12, x plus 1, but then what do you have to remember to do?
Divide by 3.
So you get x minus 4, 3x plus 1. So x equals a positive 4 and a negative 1/3. Okay. So, well, that's a bad graph, but you get the idea. We want greater than 0, so that's above the axis, so that's here and here. There is no equal to, so everything's a parenthesis. So it would be negative infinity to negative 1/3 union 4 to infinity. Is that good? All right. Let's do so what would you do at this on this one? Okay. If you wanted to start out making this positive, you can multiply everything by a -1. If you multiply by a negative, what happens to your inequality? It will flip. If you're going to try slip and slide, do you have to multiply by that negative first? No, you could just try your slip and slide, so both options work. If we do the slip and slide,
Don't work.
oh, that's a problem. Is there anything that multiplies 15 and adds to 1? No. So what do we do when things don't factor nice?
Quadratic formula.
Okay.
Oh.
We're completing the square.
No, quadratic.
So opposite of b would be -1 plus or minus the square root of b squared minus 4 times a times c all over 2a.
Can we take our negative out and then do all?
So I get 1 minus 60. So I get a negative 59 under my radical. What does that mean?
Irrational.
Can we, when your zeros are imaginary, what does that tell you about your graph?
It's not there.
It doesn't touch the line.
It doesn't actually hit the x-axis. Did this graph open up or down?
Down.
Down. So it opens down and never hits the x-axis. Graph it on your calculator real quick and just double check that. If you put in your negative 3x squared plus x minus 5.
You don't touch the x-axis.
Graph the original.
Oh my god.
It doesn't touch the x-axis. I do.
So we just get something like this, right? Never hits the x-axis. So now let's look at the question. I want to know when it is greater than or equal to 0. So when is this thing above the x-axis?
Never.
Never.
No solution. No
So
x-axis.
no solution.
Would you still be splitting our final answer into 2 parts?
No, because, I mean, you can, but you won't even need this in your answer. Your answer is a no solution. What if I said,
Oh, I'm pretty sure.
What if you didn't say?
Whoa, this is a display.
hold on.
No,
Let me
I just
rethink.
started writing it.
Okay, I'm just gonna change, what do I want to change? Alright, we'll go with that.
Another dollar.
But we don't want our quick. I'm sure.
So what would I need to do here?
Get it all on the same.
No,
Subtract the 2x and add the 1.
Okay, so everything has to be on one side. It doesn't matter which side you take it to, but typically, whoops, you guys like to have a positive x squared.
Yeah, I can do it.
Maybe it doesn't.
So keep in mind this is the same thing as saying x squared minus 2x plus 1 is greater than 0. Does that factor nicely?
Yes.
Okay, what multiplies to 1 and adds to -2?
X minus 1 squared.
How, you know,
So we only get one for our answer.
that means it'll always be, because it bounces.
So let's look at this. We have
No
a
solution.
quadratic, it opens up because it was a positive x squared. I want to know when it is greater than
Your sign changed.
0.
Always.
Maybe
Or, it'll
Oh,
be.
yeah.
Wait, why'd your
but
sign
zero.
Everything, everything was zero.
She just flipped
Flips
sides,
it to the other side.
Come on, Lane.
just so it was more like you're used to
It
seeing.
wouldn't be always.
So
So everything was
I
zero.
want when it's greater than 0. So that's here and here. But at that point, when x is 1, it equals 0. Did I have a bracket here?
No.
No, so I don't want when it
If
equals.
everything not equals zero.
They-
Anything,
Wait, negative
Oh,
infinity
yeah.
to zero equals.
Negative infinity to 1, because you have to do the x value. You need 1 to infinity.
Wait, how can why is there a union now?
This is saying it's everything except that point 1. Okay. Other questions? Really? You guys don't think you need any more examples?
No.
I think it should be a math
I
exam.
think I need help for a little bit of
There is a Math Excel assignment posted. You've got time right now